I am very happy to have you here, and in this video we will be looking into types of chemical reactions. But before we go for these types of chemical reactions, it will be very important that we know what a chemical reaction is all about. But if you are being asked what is a chemical reaction, a chemical reaction can be defined as a process by which atoms of substances interact with one another to form new substances. It can be grouped under combination reactions, decomposition reactions, displacement reactions, double decomposition reactions, catalytic reactions, reversible reactions, thermal dissociation reactions, combustion reactions, oxidation and reduction reactions. And each of these will be treated in this video. Please pay attention and don't forget to subscribe to my YouTube channel if this is your first time watching me. But if you have done so, make sure you help me share this work for others to view. Let us start with combination reaction. Another name for combination reactions can be synthesis, direct combination, or composition reaction. This type of reaction involves two or more substances coming together to form only one compound. That is to say, at the reactant side we are going to see more than one substance, but at the product side we are only going to see only one compound. It can be done by element coming together to form one compound, as we can see in formation of water, hydrogen peroxide, ammonia, and sulfur 4-oxide, and many more. It can also be between element and compound coming together to form a compound, as we can see in formation of carbon 4-oxide, sulfur 6-oxide, and many more. We can also see it as compound coming with a compound to react to form a compound, as we can see in formation of ammonium chloride, lead 2-tetraoxosulfate salt. What about decomposition reaction? A decomposition reaction is a type of reaction in which a substance breaks or splits into two or more simpler substances. Here, at the reactant side, we only have one substance, whereas at the product side, we have two or more substances there. And if you look closely, you will see that the decomposition reaction looks more like an opposite of direct combination reaction. Most times, energy is supplied for this reaction to occur. If it is heat that is supplied, we call it thermal decomposition reaction. If it is light, it is more of photolysis. If it is electrical energy that is supplied, we call it electrolysis. Sometimes even catalysts are used to break such compound as catalytic decomposition reactions. We still have displacement reaction. A displacement reaction is a type of reaction in which an element replaces or takes the position of another element in the element's compound. As you can see, A plus B, C will give us AC plus B. Here, A is standing in the position of B in the compound BC, here as AC. For this reaction to occur, it means that A and B are either electropositive elements or they are electronegative elements. Secondly, it means that A is above B in the reactivity series. I know you may be asking question now, what do I mean by reactivity series? A reactivity series is a table arranged in the order of increasing ability of some elements in their reducing or oxidizing power. Something like potassium, sodium, calcium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Now you may be asking, how did I manage to read this offhand? It is simple, and you can also do the same thing. How did I do it? I use mnemonics in my head. K na car, magi allow, season feeding snail, plumb high current, hajia, oru. That is for metal reactivity series. We still have non-metal reactivity series. But here I inverted it. Rather than using the direct up to down, I use the down to up. What I use as mnemonics here is pick, brain, cloth. Pick, brain, cloth. Where PIC is phosphorus, iodine, carbon. Whereas brain is Br and N. Br is bromine and N is nitrogen. Then the cloth is ClOl. Where the Cl is chlorine, the O there is oxygen, and the F there is fluorine. Mind you, I'm starting from down up. Another way I can use to remember this is Paulina. I can bring nitroclinics or flowers. If you like this, you can use this or the other one. This means that potassium will displace aluminium. Aluminium will displace tin. Tin will displace hydrogen. Copper cannot displace tin. Mercury cannot displace carbon. Gold cannot displace sodium. Do you get it? Okay, the same thing is fluorine can displace any other non-metals. Fluorine can displace bromine, nitrogen. Nitrogen cannot displace oxygen. Carbon cannot displace oxygen as non-metal. Phosphorus cannot displace chlorine. Iodine cannot displace chlorine. That is, if we have something like this, sodium chloride reacting with bromine, it is impossible because bromine is below chlorine in the reactivity series. But if you have something like sodium bromide reacting with chlorine, it is going to give us sodium chloride and bromine liquid. That is because chlorine is above bromine in reactivity series of non-metal. The same thing goes with when we have potassium as a metal coming in contact with zinc tetraoxosulfate 6. The potassium will displace zinc in the reaction and deposit zinc as a metal. Another type of reaction we have to look into is double decomposition reaction. Here we have two substances decomposing or splitting or breaking into two substances, two different substances here by exchange of radicals. If we have AB plus CD, it will give us AD plus CB. This is because there is just an exchange. To demonstrate this thing in reality, if for instance we have end of the year party, here I am to come with my gift, you are to come with your gift. Here I am with my gift and you are with your gift. And they say this is the time for exchange of gifts. Let's assume that your gift you are holding is electronegative ions or radicals, and you as a human is electropositive ion. Now, I will bring out my gift and give you, and you will give me your gift. That is what happened in double decomposition reaction. Double decomposition reaction is divided into neutralization reaction and precipitation reaction. What do we mean by neutralization reaction? It is a type of reaction in which an acid reacts with a base to form salt and water. It can also be defined as a reaction in which a hydrogen ion or hydroxide ion from a base neutralizes a hydrogen ion from an acid to form water. Example of that can be seen in sodium hydroxide reacting with hydrochloric acid to form sodium chloride and water. If you look at this reaction, you will notice that of ion exchange. Here, the chlorine as the chloride from the hydrogen compound with chlorine now exchange moved the sodium. That is how it happens. I hope you get that. Okay, for us to know if there is a reaction occurring here, we normally use indicators. For precipitation reaction, this is a type of reaction in which one of the product is insoluble. As you can see on the screen now, you see that we have many of them that are soluble in water and some that are not soluble. And we even have a table for this. Now you may be also asking yourself, are they going to give you this table in exam for you to use to know whether the reaction will happen or not? No, they expect you to have this in your memory. How can we have this in our memory when most of us have poor retentive memory? Therefore, to help you to have this in your memory, I created a song for this. Don't mind how my voice is, don't mind my expression, just mind the wordings and the tunes. Make use of the tunes to remember them one after the other. I do this to make chemistry easier for you and I. The song goes like this. All compounds of linake, rubidium, cesium, ammonium are soluble in water. All compounds of triazole, nitrate 5 and acetate are soluble in water. Just remove lead, silver, mercury, iron, then all halides are soluble, and remove lead, mercury, strontium, barium, all tetrazones, sulfates are soluble. For gold 3 2 minus, Po 4 3 minus, they are insoluble. Just remove linake, rubidium, cesium, ammonium, all hydroxides are insoluble. If you remove linake, rubidium, cesium, ammonium, strontium, and barium. You can sing the song over and over again. The more you sing it, the more it stays in your memory, and the more you have this, and you can be able to answer questions that comes after it. For instance, we have something like silver triazole nitrate 5 reacting with sodium chloride. They will ask you, can this reaction be a precipitation reaction? Or they can ask you, what type of reaction would this give? If you look at the song or look at the table very, very well, if you can record the song or look at the table very, very well, you will notice that there is a place I call halides. Halide means halogen ions. Now, examples of halogens include fluorine, bromine, chlorine, and iodine. Now, we have silver triazole nitrate 5 reacting with sodium chloride. Now, since it is a double decomposition reaction, they are going to have exchange of radicals. Do you get that? Now, this chloride will go for silver and the triazole nitrate 5 will go for sodium. Now, if you look at this, sodium triazole nitrate 5, according to the table, all triazole nitrate 5 are soluble. This one is soluble, this one is soluble. But their products are not soluble because silver chloride is not soluble in water. Therefore, you're going to see a precipitation of silver chloride. Now, that means that this is a precipitation reaction. But if you have something like calcium triazole nitrate 5 reacting with potassium bromide, they will ask you, can this reaction be a precipitation reaction? To be frank with you, if you join these two inside water, you will not see any visible reaction because each of them are soluble in water. Each of the ions are soluble in water. Now, if we go back to this silver triazole nitrate and sodium chloride, now if we split it to use the ionic equation, we are going to have aqueous sodium, aqueous chloride reacting with aqueous silver ion and aqueous triazonitrate 5 ion to give us aqueous sodium ion and aqueous triazonitrate 5. But that silver and chloride will join together to give us solid, insoluble substance. Therefore, if we remove the similarities, the similarity is in everything, they are similar in everything. Here you have sodium is plus and aqueous at the reactant side. You also have sodium is plus and aqueous in the product side. Therefore, we remove it. Now we go again, chloride, aqueous in the reactant side, but it's not the same at the product side. Therefore, we'll leave it. Now when we go for the silver ion is plus and aqueous at the reactant side, but not so at the product side. We leave it. But triazonitrate 5 aqueous at the reactant side and also at the product side, we are going to remove them. Those ones I remove, we call them spectators. Whereas the remaining one you can see now is what we call net ionic equation. Now if you join this thing back, we have what we call complete ionic equation. Now I would like you to do the following for me. I believe you must have done the little work and you can see the answers on the screen now. Now there's something I want to tell you. Make sure that you try this work because it shows that you are understanding what I am doing. And if you are understanding what I am doing, it makes me happy. I'm also going to make you to share my work happily. But if you are not understanding what I am doing, it will not make you happy to share it for others. That is why you should practice when I ask you to practice on my videos. Let us go for catalytic reactions. Catalytic reaction is a type of reaction that involves a substance that does not participate in the reaction fully, neither does its chemical quality or quantity changes after the reaction, but the presence of this substance helps in altering the speed of the chemical reaction. We can see that in formation of sulfur 6 oxide, Haber process, and many more. What about reversible reaction? A reversible reaction is a type of reaction in which the process can proceed in two ways, both the forward reaction and the backward reactions. Example of that can also be seen in the Haber process, mostly used in ionic equations. Let's go for thermal dissociation reaction. A thermal dissociation reaction is a type of reaction in which substances breaks while there is heat, and when it is cool, they comes back. That is to say, a thermal dissociation reaction is a reversible reaction. You can see that in nitrogen 4 oxide forming dinitrogen 4 oxide due to increase in temperature and reduction in temperature. I still have combustion reaction for you. Combustion reaction is a type of reaction in which substances burn in oxygen to produce water and carbon 4 oxide. When it is burning in limited supply of oxygen, we normally have carbon 2 oxide, but mostly we supply air so that it can produce carbon 4 oxide and water. Example of that is seen in hydrocarbons burning in oxygen. As you can see at home, your gas cooker. Also, we have something like alkanols burning in oxygen to form water and carbon 4 oxide. We have the last one, the oxidation reduction reaction. This is a type of reaction in which one substance is oxidized and the other is reduced. When you come over to the video of oxidation reduction reaction, you will understand better what I mean here. Thank you very much for watching this on my YouTube channel, and don't forget to share this with your friends on your social media in order to help me to grow as you are learning.